Everyone. Today I'm going to be talking about how we relate partial products to the standard algorithm. In my class we've been talking a lot about partial products when it comes to two-digit by two-digit multiplication, and we've been trying to figure out how it relates to the standard algorithm. So today I'm going to be working through a problem. I'm going to be working through 25 times 24. And I'm going to start by over here on the partial product side. In my last video, I talked a lot about partial products, two-digit by two-digit. If you need a quick refresher about how to do that, you can go over and click on that video. But I'm going to continue on over here. So when I talked about two-digit by two-digit partial product, our first step was to put everything, all of our numbers, into expanded form. And 25 in expanded form is 20 plus 5, and 24 in expanded form is 20 plus 4. The next thing that we do in our partial products is we create the box, is what I tell it to my students, or how I call it. And so we create our box, and I'm going to put 25 on the top, so 20 plus 5, and then on the side I'm going to put 20 plus 4. Remember, when we're making our box, whenever we see an addition sign on our top number over here, we're going to put a vertical line, and whenever we see a addition sign over on our left column, we're going to put a horizontal line right where we see it. So now we've set up our box. And so I'm going to go over into our standard algorithm. When we set up our standard algorithm, it's a lot like when we do two-digit by one-digit multiplication. I'm going to put our larger number up top. If you want to, you can do 24 times 5. When we multiply, you can multiply you can put either number on top and either number on bottom, and it will get the exact same answer. But for this problem, I'm just going to put 25 on top and put 24 on the bottom. When we do standard algorithm, we're multiplying 4 times 5. So up here we'll do 4 times 5. I know 4 times 5 is 20. But 20 has a 0 in the ones place. So I'm going to put a 0 in the ones place, and I'm going to carry that 2 over into the tens place. Now, I said we multiply 4 times 5 because we're in the ones place. I'm going to go back over to my partial product, and I'm going to see where 4 times 5 is on our partial products box. Well, I know when I multiply horizontally from our number over here. And so 5 times 4 is going to go into this box right here. And 5 times 4 is 20. So I'm going to put our 20 right there. The next thing we do is we come back to our standard algorithm, and we're going to do 4 times 2. 4 times 2 is 10, plus our 2 is 12. And since we don't have another number over here to carry over, when we do 4 times 8 is 10, plus 2 is, 4 times 2 is 8, plus 2 is 10, not 12. And since we don't have another number over here, we're just going to put the 10 right here. Now, this isn't 4 times 2. Our 2 up here is in the tens place. So it's 20. So 4 times 20. I'm going to go look on our partial products box, and I'm going to look. Do I have a 4 times 20? I do, right here. 4 times 20. So I'm going to put my 4 times 20 right here, and I know 4 times 20 is 80. The next step I tell my students is that we multiply the 4 by everything up top. So I'm going to cross it out. I know that I'm done with it, and I'm going to cross it out just so I don't accidentally multiply my 4 when I'm going over into my next place value. So my next place value is in the tens place, the 2. And since I'm going over to the tens place, I need to have a representation that I'm doing that. So I'm going to put a 0 right here. This 0 shows that I'm no longer multiplying in the ones place, but multiplying in the tens place. And so now I start to multiply. 2, and I'm going to cross out this so I don't get confused because that was from my 4. 2 times 5 is 10. And so there's a 0 in the first place value in our 10, and I'm going to carry the 1. Now this is really 20 times 5. And so I'm going to look for 20 times 5 in my partial products box. And I do have a 20 times 5. 20 times 5. And I know 20 times 5 is 100. So I'm going to put a 100 right there. And then over here, I'm going to go back to my standard algorithm. 2 times 2 is 4. Plus 1 is 5. So I'm going to put my 5 right here. But this is not 2 times 2. We're in the tens place. So this is really 20 times 20. And when we do 20 times 20, it's right over here in our partial product. So 20 times 20 is going to be 400. Now, at this point, I tell my students that we're now going to go over to the 2 again, and we multiply the 2 by everything up top. And when my students tell me yes, I'm going to cross it out. That way I know I'm done. And when I have no other numbers to move over to, that's when I know I'm going to start to add. When I have no other numbers at the bottom to multiply by. So I'm going to add. And at this point, I stopped my students. And I said, look, now in both the standard algorithm and partial products, we're on that adding step. So I had them take a quick minute, maybe about 10 to 15 seconds, to try to find a connection between our partial products box and where we are in our standard algorithm. For those who haven't seen it before, I'm just going to wait a little bit, and you can pause the video if you want. And I want to see if you can make the connection between where we are in the standard algorithm and where we are in our partial products. Okay, so hopefully you've had a little time to think about it, and I'm going to show you where it is. So when you look over here in our standard algorithm, we're adding 500 plus 10. Well, where did these 500 and where did this 100 come from? In my class, we started talking about, we did partial products first before we did standard algorithm. And if you see right here, 400 and 100, we add the numbers in our partial products box together. Well, this 400 and 100 equal 500, and the 500's right here. And when we look at our 100, we can find 100 over here at 80 plus 20, which is right here. So in my last video when talking about partial products, 2-digit by 2-digit, or even any partial products, what we do when we find everything in the box is we add it together. Well, if we add all of our numbers together, 400 plus 100 plus 80 plus 20, here we're adding 4 numbers together. We're adding to get 600. Here, we're only adding 2 numbers. We're only adding 100 plus 500, which would give us 600. So when we talk about partial products in standard algorithm, It's not that one is better than the other. It's just that when we look at partial products, we're really breaking it down into place value. And when teaching students about multiplication, when they come from younger grades, they really know those math facts and they're really able to multiply by place value. So that's why a lot of educators start with partial products, because it's a lot easier for them to visualize and to understand, because they've been working with place value for a lot longer time. When we talk about the standard algorithm, it's just a little more efficient. As we move on to older grades, we really focus on efficiency. What is the efficiency? You understand the concept of multiplication, but now we have to get more and more efficient. And so here, we're only adding two numbers together, 100 and 500. And here we're adding 4. So what the standard algorithm really does is it takes away a couple of those steps when it comes to addition. And that's why this is how they are related. Very similar, just a little more efficient when it comes to the standard algorithm.